the take the best heuristic is a simple lexicographic structure. So you have a number of reasons on which you base your inference. But you don't now add and weigh all of these reasons, but you order them. And ordering is an important principle that's not part of many so-called rational theories. So you might have a choice between two options, and the first thing is a queue, and if it allows a decision, that's it. If it doesn't allow a decision, you go to the second one, and that's made. That's the idea. Give you an example. Two of my former pre- and postdocs have asked the following questions. Where would a burglar break in? So there are two options. And they tested take the best as a model of this decision making against a weighing and adding model. And first they used undergraduates. And undergraduates don't know very much about breaking in, hopefully. So what they found is that most of their judgments between two locations that differed on, say, whether the letterbox is full or not, whether there's an access on the ground floor, whether there's an alarm, and so on. And so most of them were best modeled with a linear weighing and adding structure, which basically reflects, I think, in this case, that I don't know where to look at everything. Then, here's where most psychological studies stop. But since we are working with the real world, so the two authors next tested experts, real burglars who were in London prisons. And they had allegedly about 60 or so successful breaks-in behind them. That's probably an underestimate because that's their own estimate. And now you ask this one, what's the best thing to break in? And the judgments of the professional burglars could best be modeled no longer with a linear additive structure, but with take the best. And the most important cue for the burglars was whether there's an alarm or not. If one location had an alarm, the other one not, that's it. But if both have an alarm, or none of them, then you need to go on to the next one. Interestingly, police officers were also tested who hunt burglars, and also most of them appear to follow take the best, not a linear weighted structure. It's just that their criteria, their order was different. They did not exactly understand what the burglars' hierarchy is, but they thought that access at the ground floor would be the most important thing. So how do people know how to rank the cues? The burglar example is one where you basically have experience. And the experience of people will differ, so not everyone will have the same cue order. And the policemen, which are afterward, have this indirect experience, and that appears to lead a slightly different order. The second, so this is learning by experience, like many things. We also have good hints that orders can be genetically coded, particularly in animals, who often do similar lexicographic decision making. And finally, a very important source is that people are being taught what to look at first. And that happens, for instance, in medical school. It's not that medical doctors would learn by experience what treatment to apply to you. That would be much dangerous, individual learning. But they are being taught by others what to do. And a number of medical decision making can be modeled in a similar way as take the best, which we call, in this case, fast and frugal trees. That is a categorization problem while take the best is a choice between two.